Hello. How is everyone's morning, evening, whatever time zone you find yourself in? Hopefully my audio's coming through okay. Had a few issues last week, which I think I've rectified, hopefully, but obviously if all you see is this, then please say something, because I have literally no way of knowing whether the audio is clear or not. But yeah, let's give it a few minutes for people to filter in, and we'll kind of go through what we're doing today. All fine, good. I watched the stream back from. Cool. All you can hear me. That's great. Yeah, I watched the stream back from last week, and yeah, I noticed that the audio was not great to start with. So apologies for that if you were here, and thanks for coming back again if you were. I also noticed that due to the way I had my setup, I had my code editor off to the left. So when I was coding, my voice was getting further and further away from the microphone. So I've tried to realign things a little bit better. So hopefully I'm talking more into the mic a little bit more consistently. Yeah. Hello. Cool. Okay, so I'm going to start. What's process hacking? Well, let's start off with a quick recap of what we're doing and where we're planning on going with this. So, if any of you have watched any of my videos before, so one, thank you very much. But two, I do a lot of video game hacking, and there's a lot of boilerplate on the software engineering side of that, on the programming side. You know, process injection and function hooking, and basically driving the platform APIs to get games to do things that they were never intended to do. So I've been thinking for a while, I'd quite like to build like a toolkit or a framework or just like a blob of code that does all this boilerplate for me. And then it just, I can just reuse that on each video, which in theory, hopefully means it's quicker for me to produce videos. But I also wanted to try out live streaming. So I figured let's kind of bring those two together and give it a go. So that's where we are. We're kind of building out a little toolkit for messing around with processes as they run. So last week, what did we do? We basically we set up the project and then built out like a very, very basic little API, which exposes a process. Oh, first, actually, before I continue, is the text large enough? Do I need to embiggen it, or can people read? Again, it's very legible for me, but it's very hard for me to tell how other people can see it. I can go a size bigger if that helps, or we can leave it as this and I can keep prattling on. Okay, well, text looks good. Okay, so we built out a little process class which is going to encapsulate a running process, or like a dynamic view onto a running process. So this will be backed by, an actual thing running on your computer, and the idea is that as we add more functionality, it will allow us to interact with it. Kind of spoiler alert to what we might be doing today. So we basically just drove the Win32 API to achieve this result, and let's find, and then we actually wrapped it all up into, this is how we drive it. So we can search for a process, so anything that matches Firefox.exe, and then we can loop through it, any process that matches that, and then we can get the name, which is Firefox.exe, and then the PID. So that's what we did last week. Kind of took a little bit of a detour into a few little abstractions. I had an absolute blast. Hopefully everyone else enjoyed it as well. So yeah, we're going to kind of expand on that a bit today. I'm kind of glad this works, because just before the stream I made the fatal mistake of upgrading my compiler to the latest MSVC. So I'm glad that still works. Otherwise it might have been a very, very short stream or a very long stream, depending on how much debugging we would be willing to put up with. But anyway, let's get going. So today I want to look at memory of a running process. So we want to be able to inspect the memory of a process, and eventually we want to be able to interact with it. We want to read to it, write to it, remap it, all that kind of stuff. But I think to start with, we just want to see what memory a process has allocated. I think there's a better way of me kind of describing what the outcome of today will be. So let's find an app, Humble Calculator. So this is a process. It is running on my computer, and if I bring up a debugger and I attach it to that, this debugger will show me all the mapped memory regions. So this is kind of what we want to get by the end of the stream. We want to be able to list all the addresses where memory is allocated, the size of it, and then the protection. So is it read, write, executable, or some combination of all three? So if that makes sense, we're going to basically try and reproduce this table. It's a lot of numbers. Some of my favorite ones are in there. A, B, some absolute classics. So yeah, that's what we're going to do. And basically the way I think we're going to do this is we're going to start off using the Win32 API to kind of get this data, and then we'll check it works, check we're happy with it, and then we'll kind of build out a bit of an abstraction to make it kind of usable for an actual end user to use. Just in the test card from your start stream, are you British? Yes, I am. I don't know if my voice, my accent gives it away, but yes, I'm from Blighty. So yeah, we'll build out the abstraction, we'll make it usable, and we'll see where we go from there. So let's start writing some code, shall we? So I think in this process abstraction that we've got, let's just do like memory regions. Eventually, I think this will return a thing that represents the memory regions, but let's just start getting some code in there and starting to write it. Because yeah. So void process memory region const. Right, brilliant. We're done. Let's ship it. How different are Windows programming and Linux programming? It's a really good question. Like they are both the same and also very different. As in, a lot of the concepts are the same. You have processes and you have threads and you have like kernel primitives. You have mutexes and locks and all that sort of jazz, but the actual interface varies very differently. Like the code you have to write is very different, but you're fundamentally kind of doing the same thing. Windows and Linux are very, they're solving a very similar problem under the hood, right? My plan for this is to port this to Linux because I think it'd be kind of a fun problem to solve. It's like, hey, we take all this Win32 specific code and how do we abstract it in a way that then allows us to also run that, have it run also on Linux and Windows. The deeper you go, the more they differ in implementation. Yeah, absolutely. Like, I mean, even at the surface level, like there is no K32 enum process. No, that's a bad example. There's no, where's our process utils? There's no enum processes, K32 enum processes really equivalent in Linux. You go to /proc and then enumerate all the fake files that represent, all the fake directories that represent all the processes. So we'll definitely do some Linux programming at some point. I think that'd be fun. When, who knows? Like, I don't want to go so far down the Windows route that it's then hard to bring back and then redo for Linux. But at the same time, I don't want to keep ping pong between Windows and Linux because we'll never actually, it'll take ages to add new features. So we'll see how it goes. Most things have cross-platform libraries that you can use to write the same code for both. Yep, absolutely agree. Try and do as much of this as possible without bringing in third-party libraries, just because I think it's a fun challenge, and hopefully it'll show people kind of, how you do this, I guess, systems level or OS level programming. But yeah, that's a valid point. Okay, so speaking of platform APIs, we're going to use VirtualQueryEx today. So VirtualQueryEx retrieves information about a range of pages within the virtual address space of a specified process. So that's a lot of words, and I appreciate they might not all make sense. So let's get up a diagram. So your computer has RAM, starts at, I don't know, OXO and goes up to some big address. When you have a process, this process has what's called virtual memory, so it kind of has its own address space of memory, which also starts from OXO and goes up to OX, I don't know, FFFFF. And the idea is that as your process is running and it requests memory from the kernel, which I guess kind of lives here, it gets mapped to random different blocks of physical memory. So the address that your process sees, hang on, how do I remove let's just hide those messages. So yeah, the virtual memory that your process sees is kind of backed by physical memory, but the addresses can be different. They can be like wildly different. The idea is that your process will see a consistent set of addresses, and different processes can kind of all view the address OX7FFF, and it doesn't matter that that's not the actual place it lives, because the programs just can, live within their own self-contained virtualized address space. So basically what we want to do is we want to find, in this virtual address space, we want to find all the pages, so the 4096 byte blocks that have been allocated to the program. That's what we saw in the debugger. So what this sorry, I'm my own moderator, so how do so basically what this API will do is you'll give it a starting address. We'll go through all the arguments in a minute, but basically you give it a starting address, and then it will basically tell you the amount of bytes that are effectively similar. Sorry, this is incredibly distracting because someone is abusing the comments section, the chat section. I may have to switch chat to subscribers only or something, which would be a bit of a shame. Anyway, what this API do is you'll give it an address, and then it will basically tell you the block of bytes that... This is really not my day today. Apologies for this. I don't even know how to stop people coming back. Anyway, whatever. Let's just start programming. I'll explain it as we go along. Basically, you're going to give it a handle to a process. So this is the handle to the actual process. The spam isn't coming through via chat, as in you're not seeing it. Am I catching it quick enough? Because I'm getting like a load of spam coming through of people saying the same ridiculous thing over and over again, and I'm going as quick as I can to kind of hide it. Here we go. Here comes another one. Okay, fine. Okay, fine. I will just ignore it then, and I'll just try and read the messages through it because it's very distracting and it keeps taking me away from what I'm trying to explain, which isn't producing probably a great viewing experience for anyone. So we're going to use this function called VirtualQueryEx, and this will take the first argument, which is a handle to a process. So this is just a Microsoft construct which represents a running process, which we've already built and kind of abstracted. So we already have access to this. We will then give it a pointer to the base address of the region of pages to be queried. So that's quite a mouthful, but this basically is going to be, we're going to point it to an address within the virtual memory space, and then it's going to start telling us information from that address onwards. And then this is going to be a pointer to a memory basic information structure. So this would be the output. So this is where the resulting data will be stored, and then the size of the buffer pointed to by this. So this just tells the API how big this buffer is. So what actually happens is, so this is the bit I was trying to get to and we're getting distracted, is you'll have like a whole bunch of memory which will have different, it might be unallocated. So, these early sections in the OXO are probably not allocated. You'll have some that are, marked, let's pick a better color. You'll have some that are read-writable, some that might be executable, some that might be just readable, blah, blah, blah. And the idea is that you give it an address and it will tell you all the information up until the next page where like the information about it is different. So it'd be like, if this is unallocated, then it will tell you all the unallocated memory up until something's allocated. And then we can call this function again, pointing it at here, and it will tell us about all the stuff until the information changes and blah, blah, blah. So by doing this iteratively, we can basically piece by piece, chunk by chunk, pull out all the information we need about the memory of the process. Yes. Oh, I think I see. I had it on. Yes. Thank you, Dean for pointing out. I had it on the live chat, not the top chat, so I was just seeing all the spam as it was coming in. So I've changed it now. Are handles the equivalent of file descriptors in Linux? It's the same concept. They are just like effectively an integer handle, which the kernel kind of knows what it means. A file descriptor is a handle to a file, whereas a handle in this case is the big angry uppercase handle in Windows is a handle to a running process. Hope that kind of makes sense. So yeah, basically we're going to drive this, and we're going to basically keep going. We're going to pull out all the information and see what we get. Usually, it's always worth reading kind of like the return value and the remarks and kind of get an idea of what we're getting ourselves in for. So the return value is the actual number of bytes returned in the information buffer. That's fine. And then if the function fails, the return value is 0. So basically, we're going to keep calling this function until it errors, because it will error when there is no more memory to enumerate. I think I've spoken quite a lot and got myself quite distracted. Apologies for that. So let's start writing some code. So the first thing we're going to want is this memory basic information struct. So this will be the results. This is where the function is going to write all our data to. And then we will do I think that Linux is suitable for hacking, reverse engineering games? There doesn't seem to be good equivalents of stuff like Cheat Engine. I don't, because I do a lot of it from scratch, I don't actually really know what the kind of prior art is. So like all Windows and Linux have great debuggers. That's kind of all you really need if you want to kind of get going, and you can write C++ on both of them. So kind of using what we're doing, yeah, I don't think it really matters. And some of my videos, I've actually deliberately chosen the Linux version rather than the Windows version, just for a bit of variety. So then we need we need an address to start, getting information from. So let's do address 0. So we're going to start at the beginning of the virtual address space, and we're just going to keep going until we've enumerated all the virtual memory and hopefully gotten information about it as we go along. I need to include C std_def for access to std byte, and then I can do while VirtualQueryEx, and this took the handle, which is already a class member from this class. We built that last week, so we already have access to the handle, and then the address of we want to read from, and then the buffer we want to write our results into, and then I think the last one's like the size of the size of the struct that we're going to write the results into. So whilst that doesn't equal 0, which is the error. Again, it's kind of, Win32 API is a little bit annoying sometimes like this. There's no way of it to tell you ahead of time, there are these many regions and you should read all of them. It's just keep going till it errors, and good luck. Hope you got them all. Obviously, do shout out in the chat if anything doesn't make sense or I've explained something poorly. I'm happy to go over things. So the next thing we want to look at is what's inside. Bring me docs page back. What's inside this memory basic information? So what is Windows going to give us back? And it gives us back all this. So it gives us back a base address. So this is a pointer to the base address of the region. Obviously, we kind of put that in, but there are some situations where that might differ, but we don't really have to worry about that. Pointer to the base address of a range of pages. Again, we're not too worried about this. What we are really interested in is the region size. So this will tell us how many bytes, how many bytes this struct is telling us information about, if that makes sense. And then we also want the protect. So this is the memory protection. So this will tell you, is the memory readable, writable, executable, or some combination of all three. And somewhere, memory protection constants these are the possible options we can get from that. So it'd be execute, or execute read, or execute read write, where for some reason read write doesn't have an underscore between it, but execute and read does. And there's a whole load of like other ones which are either Windows specific or quite like situation specific. So we're not going to really worry too much about these. To start with, we're just going to worry about the big three, which is readable, writable, and executable. So yeah, okay, let's start writing some code. So now that we kind of know what we're getting, oh, actually, I lied. There's one more we care about, and that's the state. So this is the state of the region. So it could either be free, so it's unallocated. It could be reserved, which we're not too worried about, or it could be committed, which means it's actually been allocated. So the first thing we want to do is loop through all these regions and check if they're a free region or if they've been allocated. If they've been allocated, then we can introspect them a bit more and get a bit more information out of them. So let's try that. Let's try that. I think that sounds like a good idea. So if I'm hoping the autocomplete is going to help me out here. State equals mem commit. So this means that the block was allocated, so we can now get some information out of it. And let's go include print. Let's stood print ln. I'm going to want to get the 3 bits of information that I said we care about that I've already forgotten was the mem info base address, the mem info region size, and the mem info protect. So I think that's a big that'd be a good place to get a start. Just arrived. What does this do? So maybe I should have a pinned comment which explains this. But basically, we are writing a process hacking toolkit framework, something that allows us to easily manipulate processes as they're running. I'm going to kind of be using it hopefully to streamline future videos that I make, but I think there's quite a lot of interesting low-level C++ and OS knowledge that kind of goes into building something like this, and I thought it'd be kind of fun to share that with everyone. Oh, someone's already replied. Thank you. Right, let's see if this blends. Brilliant. So now that we have got this loop already, let's change this to calculator, because I don't want like loads of processes, and I'm pretty sure I've only got one calculator running. Proc.memory regions. So this is not a great API. We will change this. Like you call it, and then internally it just dumps a load of stuff to stud out. But it's enough to get us going. Debug console. That was 100% not what I was expecting. Let's see. Right, let's see if we can debug that. Where have I gone wrong? It's because I've got a debugger still attached to calculator. Let's just stop that and start up calculator again. This time unattached. Okay, nope, that wasn't it. Interesting. Where have I gone wrong? Is this even getting in here? Okay, why is it not finding calculator.exe if I've got a casing issue? Oh, let's go back to Firefox.exe then. So that definitely worked. And it's definitely doing something. Nope, it's my fault. I'm surprised we haven't got this far. We are stuck in an infinite loop because I am continuously querying the same address over and over again and never updating it. So that's why that's not really working for us. So what we need to do is update the address based on the region size that this function returns to us, because that way we'll keep advancing that address and getting like the next block of information and then the next block of information. I bet this will work now. Calculator. You're right, someone said it might be calc. Should. Yeah, let's try calc. If not, we'll go back to Firefox because no one's particularly interested in watching me play guess the executable name. Okay, fine. Let's. Unless I've got another bug somewhere, I'm pretty sure that's right. There we go. Right. Okay. Whew, got there in the end. Turns out I don't know what calculator is called on my system, but I guess that is irrelevant. So what we're printing out now is the address of a block of memory, how many bytes are in, so the address of a region of memory that process has allocated, how many bytes are in it, and then the protection level. This is a good start, and to be honest, that's, you could argue that we're kind of done, but I was planning on streaming for a little bit longer than 28 minutes, so there's definitely more we can do on this. Let's try and make this a more user-friendly API. So let's delve a bit more into like the C++ design side of it, because there's definitely some interesting things we can do around this. So I think the first thing we're going to want is to build a bit of an abstraction. So let's encapsulate all this information. I don't want to talk in terms of Win32 types. I don't want to hoof around my project a memory basic information struct. It's very Windows specific. It won't port to Linux. Let's build an abstraction which just encapsulates the bits of data that we care about, and then if we want to port to Linux, it might be a bit easier. So let's go new file and let's go memory region.h. Okay, so space bio, and then let's go class memory region. So this is gonna have namespace bio is just what I've called the project. I've called the project blind.io just because I'm terrible at names and it seemed to make sense at the time. So namespace bio just means that this encapsulates all my code within this namespace. So by design, the main function doesn't use that namespace. So you can see here, I have to access my functions via bio : : It just means that if you were to take this code and incorporate it into your own project, if you had your own function called find process, it wouldn't clash because mine's within that namespace. I'm coming up to 38. Is it too late for me to learn how to code and learn a language? It's never too late to learn anything. Just pick a language, watch some YouTube videos, preferably ones that are probably, no longer than sort of 6 to 12 months old, or get a book, however you find you learn best. Just start. The best way to learn to code is just to write code. So just start writing loads and loads of code. Memory region. Okay, so we're going to want to have as part of this let me bring in some useful types. Int, and I think I'm going to want def, all the classics. I'm going to want std uint pointer t address. So this will be the start address of the region. I'm going to want a size t size. So this is how many bytes are in it. And then we're going to want something for the protection level. So I think we should use an enum for this, and there's actually, Yeah, okay, let's do this. Let's go deep. Let's go deep. I don't think anyone was expecting to go deep on enums and flags in C++ today, but here we are. Memory region, what are we going to call it? Memory region protection? I think that sounds about as good as anything else. Namespace bio again, right? Because again, everything we write, we want to live within here. Let's go enum class memory region protection. Not a massive fan of the name, but we'll get there. So is high level C++ a good way to get into low level C++? I think C++ has just such a wide gamut of features and usages and complexity. It's kind of hard to really say. I think just the more you write in any language, the better you get at it. This is low level in the sense that we are going to be using the APIs at a low level of the operating system. I wouldn't say, at least, I mean, never say never, but I can't foresee we're going into that low level C++, like, you know, atomics and all that stuff at the moment. We might need it, you know, and the different memory models and all that sort of complexity. We'll see where we get to. But yeah, I don't know if that answers your question or just makes things worse. So what are the types of memory we have? I think we want to have like a default like no protection, which you can mark memory as having no protection, which means if you try and do anything with it, you'll get segfault. Kind of useful for things like guard pages, and it does have a few usages. So we definitely want to calculate. So we definitely want to handle that. And then the other ones are read, write, and execute. Where I think this is going to get interesting though is that we also want to be able to support like a blend of these. We want to be able to say, hey, this thing is readable and writable, or executable and readable, or I'm not going to enumerate all the combinations, but those are definitely some of them. So what we're going to use is we're going to use this like a bit flag. So if I set these values to be all different different bit values, so all these numbers here will only, if you look at them in binary, will only ever have a 1 in one place and the rest are zeros, which allows us to use bitwise arithmetic to combine them. We'll kind of go through how that looks as well. And if you start this one at 0, that means if there are no bits set, then there's no protection. Hopefully that kind of makes sense. I think the first thing when working with anything like this is we're going to want some way of contextualizing it, or textualizing it. I want some way of viewing it in text, right? Because numbers are like, well, let me show you. This is useless. Like, what's a 4, and how does that differ to a 32? I mean, other than the obvious numerical difference, like what does 4 mean? What does 8 mean? It's kind of useless. So we're going to want to be able to print this out in text. So let's do that. So the first thing I'm going to write is a string view, thinking about how I'm going to implement it. Let's create a toString method, and this is going to take a memory region protection. Now, I've just called this toString. You could call it whatever you want. It has nothing to do with std toString or any overloads like that. This is just a method that we're going to write, which you can pass it a memory protection, and it will return you a string equivalent of that. So let's go and make that a thing. Memory protection. Oh. Right. Okay. So this is gonna include memory region protection. Whack it in the namespace, and then let's just yoink this over. Okay, what am I doing? And then that's also going to need to bring in, why I'm using string view will make sense in a second, hopefully. And then let's just make sure this all gets built. So memory region protection. Okay, let's just check that blends. Okay, again now. Sorry, helps if I press the button. Okay, that's fine. We know it's on reference. We're going to use it now. So the obvious way to do this, I think, is with a switch statement. So we can basically handle all these cases. So one interesting C++ tidbit, I guess, is because it's an enum class, which means we have to fully qualify the name. So we have to do memory region protection, execute. I'll start with the no protection. Turn no protection. Right. Even if you use like copy and pasting and stuff, having to fully qualify this is it's a bit tedious, and I find it quite hard to read. So what we can do is using enum memory region protection. This brings in all the internal names into the scope, but just within this scope here. And then, which means we can then drop it and we can just do the simple cases. Yes, that is correct. So regular C-style enums, they leak their names into the surrounding scope. So if you just did this, then wherever you include this file, like you could just write no protection anywhere and it will resolve to this, and it leads to all sorts of miserable clashes. Whereas if you make it a class, you have to qualify it through this type, which prevents name clashes. You can also, if it's a class, specify like the backing type. So if like I really want this to only take up 8 bits, you can do that as well. But I don't really care for this. So read, write, execute, read, write, execute. Right, and then I think as well for me includes except I think if we get down here and we're like we've not been able to convert this to a name, then you've probably passed us like some sort of malform. There's probably an issue somewhere because you passed us a memory region type that we don't understand. So I think we can just sort of throw std runtime error format. There we go. Std format unknown value. I guess put it in, and then protection missing classic. Pass is not a member of std format. I never said it was. I never said pass was a member of std format. What is going on here? Is this because I've upgraded my compiler and it's now grumpy? Oh, no, it is right. Because this is an enum class, it is not implicitly convertible to an integer or to any type that this can understand. What we could do is, yes, let's do that. That's a good point. Let's make it so std format can understand our type. So we could cast this to an int. Do we want to do that? Oh no, yeah, we'll do that in a second. First of all, let's just static cast std uint 32t. Let's just, if we've gotten this far, then we're just gonna give them the raw number and say don't understand what we're doing. Yeah, I'm going to use std underline type in a second. The reason, so here's a good point. There's a reason I don't use std underline type in this very specific instance, and that is because if we later on decided to change this to a uint 8t, then this would become a uint 8t, and this would then probably try and interpret it as a character, so it would then convert this into an ASCII character, and it probably wouldn't be printable. You wouldn't get the number. So there are tricks you can do around that, but I think in this case, let's just be like, right, no, this is definitely a number. Please print it out. Will the code be public? Yeah, it's all on GitHub now. Feel free to go and look. I post on the community wall updates. Stars is, to me, a very meaningless metric, but if you'd like to go to GitHub and click the star, that's always great. Yeah, but I'll keep this updated. So basically what happens is after the stream, I'll tidy up the code, add comments, and I'll just stick it in the Git hole, and anyone can have access to it. Just do present D then. Yeah, I guess that would work. Yep, I think that's a good point. And then cast it to the underlying type. Yeah, I think that could work. Dealer's choice. Template. So I'm just going to have to check my notes because I always find this bit a little bit egregious. There's quite a lot of boilerplate for this, but I think it's struct stood formatter templated on the thing we want to format, and then there's a const. Let me check. So I've got some notes on this somewhere because I've done this before. Here we go. Right, const expra auto pass stood, and then whatever this is, format pass context ctx, and then you have to do the really weird return stood begin ctx. So this basically tells. So stood format is new in C++. It allows you to write format strings like this, like Python does, I guess. And you can overload it for custom types. So by out the box, C++ and the standard library won't know how to print your own custom types. So you can add it by specializing this, by providing a template specialization for stood formatter. And inside that, this struct, there are two methods you have to implement. Parse is how you want to handle things, like was said in the comments. Like if I had like D or something like that, I can scan through this and react to it appropriately, but for an enum, we don't care about that, so we'll just return basically what is like the default value. And then there's auto format, and then this takes a const ref to the thing obj, and then a stood format context again, which we don't need. Oh no, we do need, because I think that contains like where it needs to write it to. And then we can do return stood format to the thing that it's given us, and then the actual thing we want, and then now we can just call toString on obj. Which will now, this is why I like to write the toString first, because we end up like reusing it a lot. Classic, where have I done that? Got it. Cool, so that's done. I'm not going to overload the stream operator because I just don't think there's any value in doing it now. I might do it offline and add it up because it's a little bit more boilerplate. What I want to actually get to now is adding the bitwise operators. So you can in C++ you can overload all the arithmetic and bitwise operators, so you can kind of define what it means for a plus b if a and b are custom classes, and you can do that also with the bitwise operators. So what we can do is we can overload those for this enum, which will then allow us to basically do something like I'm just going to put MRP because I really can't bother to write it out again. Read XORed with MRP, right, and then that allows us to represent like combinations of these, which is why I've set these values to be what they are. So I think there's definitely values. Comments are hard to read on this theme. Apologies. I hope you could read it, or at least my description was sufficient. If not, again, I'll start writing some code and hopefully we'll kind of get there. So memory region protection, operator, I want or equals, or bitwise or assign, and this will take a memory protection region plot1 and a memory protection region prot2. And then we'll also do the bitwise or. But hang on, wait a minute. Not a reference, not a reference, not a reference. I think that's right. So let's go and write some code in the byte namespace. Right, so let's do. There's a reason you do this one first, the assignment one, and it'll be clear in a second. If you don't already know, it's a bit of a trick. So let's convert these to integers. So static cast stood so this is where I'm going to use the underlying type T of memory region protection prot1. So what this does is it converts from this enum class to an integer, but it's whatever integer type is backing. So again, if we go through and change this to be a 64-bit int or an 8-bit int, then this code won't ever have to change. I don't know if it's clever enough to figure it out. Oh, so yeah, so there. I went to point to the screen then, but that's actually absolutely useless for everyone watching. You can see here that it says equals int, which is the default backing type. So at least that works. 2 and then 2, and then we can do prot1 equals. Again, we're going to kind of do this dance a little bit. Region prot1 int, so prot2 int, and then we'll return prot1. So this should, in theory, provide us with the or assign operator on a memory region protection. So we can kind of all these things together. And then the reason we do this one first is because this is now trivial to implement as prot1 or equals prot2. Helps if I spell it right. Cool. Hopefully that makes sense. Just check it blends. So now we can start to build out our memory region class. So now we have access to a memory region protection, and then here we can have memory region protection, and then this is going to be a very simple class to start with. It's literally just going to provide immutable access to those values. But again, in future, we can use this to we can build on this in the future if we want to actually like read data or write data to or from those regions. So let's go. I might just see if I can do this. And then we can do what am I doing? Couldn't the enum class be part of the memory region class? Yeah, you could. I personally like just keep them separate, because it's if any other code ever wants to use this irrespective of this, then it has free access to it. It's a tricky design decision to make. Normally I try and keep things as co-located as possible, but I can definitely foresee a use in the future where something might need to reference a memory protection and have it totally decoupled from the class. But yeah, you could just as easily have declared this inside here, but then you'd have to do memory region : memory region protection. I suppose you would just call it protection. Swings and roundabouts. I have zero plan on how to kind of design this. It's very much feeling out as we go along. I'm fully prepared to make some mistakes and refactor it as we go along. So call out my design decisions, ask why I'm doing something the way I'm doing it. If there's a better way, we should do the better way. New file, memory region region.cpp. Right. include memory region, IO, and then in here we can bring in our constructor, and we can region. Let me just add this to the CMake so that it itself gets built. I'm a stickler for things being alphabetical order. Okay. Unused reference. Yeah. Well, we will let's go ahead and we'll fix all that now. Oh, something I wanted to mention at the beginning is that last time we had a load of annoying red squiggles in process CPP. It didn't affect the compilation, but it affected the IntelliSense, and someone pointed out that it was probably because there was a clash with process.h, and that was, I looked at it afterwards, and that was absolutely true. Inside the Windows toolkit somewhere there is a process.h, so I had to fiddle around with the VS Code settings to convince it that no, my process H is the one that it should care about. So yeah, I meant to mention that at the beginning, so thank you for whoever pointed that out. This is like looking in the mirror. Apologies, I'm not really sure what that means, but thanks. And then we're gonna create some getters. Pretty standard fare. Memory region protection. Make that const. So if you all read and write together, won't that correspond to 3, which does not correspond to any enum variant? Correct. That is absolutely correct. But it is well defined to be able to do that. When I first read about this trick, I was like, surely it's undefined behavior to try and stick a value that's not specified in here, like in it. But the way to think of it is, this is a new integral type that you've come up with, right? It's the size of an int or a uint8t or whatever you want it to be, and that it is valid to store any number that it can store in there from 0 up to the max value, and you just happen to have named some of them to make it more convenient. That's how I like to think of enums. But yeah, when I first did this, I was like, this can't be right. This feels wrong. But turns out it's totally legit. And let me just bring in these. Will I make a video about what I'm doing, or is it just some lives? So my plan is, this is a great question. My plan is to, each stream has like, or will have like a goal, like a single thing or a small self-contained thing that we're going to do kind of together. So today it's viewing memory regions. And then the idea is that afterwards I'll take that video and I will cut it up so that it's just the technical information. So all these kind of like fun chatty bits that we get to do, I'll strip those out so it will just become a self-contained video on that topic, and then I'll publish that for everyone. And then at the moment, past live streams are available for members, so anyone can have access to the technical content, but for this kind of side of it, you kind of either show up live or it's a perk for the members. I think that's a fair way of doing it. I'm halfway through editing the first one, so that'll be hopefully up soon. Also, it kind of helps me. It takes a long time for me to produce a video. Like, I reckon it can easily take me 3 or 4 weeks to, hack a game and produce all the content and figure out what I'm doing, film it, edit it, all that chuff. So this is kind of, I'm hoping, a way of just producing some slightly more regular content for everyone. So I'm going to try and stream regularly. I have a family and a job, and I have a family and a job. So I'm going to try and stream every Saturday, but it might not always work out, but I'll try my best. Is Is viewing memory regions not possible in something like Cheat Engine, or am I doing this for the sport? I'm 100% doing this for the sport, kind of. One, I just think it's really fun and interesting to go through, and two, I'm building out a toolkit for me to actually use to help streamline my videos. But I kind of like building stuff from scratch. It's how I learn, so that's why we're doing this. Return address. Nope, absolutely not that one. Try again. Size, and then return protection. Right. Yes, and I have a small update on membership, I guess, or something to say about that at the end. So please, that's my my subtle way of asking you kind of guys to stick around to the end. Hopefully you're enjoying it and you want to anyway. Okay, so we're pretty much done now with this class. Like, it's literally, at the moment, it's just a container for data, but it talks in either standard types or types specific to the library. So now we can start plugging that in. So inside this, we will have, I'll tell you what, let's update our API now. So this is kind of at the point where I wanted to get to. So include vector, and then also include memory. I need to give it more. Region, right. So I think memory regions should return a vector of memory regions. Okay, so this is what this function is now going to do. It's going to, rather than just printing it out, which is useless to anyone, or not useful to anyone, I should say, we're now going to return this as a vector of these types. Vector memory region, and then we can stud vector memory regions, and then return regions. Just as always, try and keep my headers up to date, because if you don't do it as you go along, you will absolutely 100% never come back and update them later. Region, and I know I'm going to need this as well. Cool. Okay, right, we're getting there. So what we can do now is regions dot pushback mem all this info, basically mem info dot base address, mem info dot region size, and mem info dot protect. This is 100% not going to compile. Absolutely no way of compiling. I mean, one, there's a mistake. Let me just fix that. But now there's no mistake. Yes, lovely C++ error. Look at that. Oh, loads of it. Love it. Right. Basically, no overloaded function could convert all the argument types. So it's basically saying that some of these types are not, the compiler does not know how to convert them into types such that this is valid, which is fair because I suspect a lot of these are internal Windows types. So what is base address is a void. So we need to reinterpret, cast that to a stud uint pointer t. I mean, we could have represented it as a void pointer internally, but I chose to not. And then I bet it's the protection, because that's going to be a Windows type. Cannot convert argument 3 dword to, there you go. Cannot convert argument 3 from dword to a memory region protection. So in placeback, you could use in placeback. Because of the way perfect forwarding, forward referencing works, there's sometimes some oddities with it. So I just tend to stick to pushback because it always does. I always know it's going to do what I want. But yeah, you could just as easily drop this and make this in placeback. I believe like the Google recommendation is to always prefer pushback where you can. It's no more or less efficient because this will take an R value reference. So this will get this PR value will all get optimized away. Anyway, what we need now is a way of converting from a D word to our internal implementation. So we're going to take a bio memory region protection. It's going to return that. I'm just going to call it to internal, and it's going to we're going to take in the Microsoft version. Right. So we're going to take in the Microsoft D word and return a type. So this will then be to internal. Right. This obviously doesn't do anything at the moment, so we need to make this do a thing. So we're going to have to get back our list of constants, if we can remember that from the beginning, and basically start applying those. So case page execute return bio memory region protection execute. Right. Hopefully you can kind of see where this is going now. So let's do the standard one. So that's execute. Is it read? Pay. What's it called? Read only. Obviously, you have execute and not execute only, and you have read only, not read. Sure, whatever. And then is it write only? Is it write? There's read write, which is both. Yes. I'm sure there's write only. Maybe not. There's write copy. Maybe that's what I want. I'll come back to that. Okay, fine. Everyone's talking about read write, so let's do that. So if it's read write, this is why we added the bitwise OR operator, because now we can return these two combined. Yes, I'm going to love typing all these out. So now we've got read write, then there's execute read, which is read and execute. To be honest, I might just do the obvious ones and then in slow time just add the rest, because no one's really here to watch me try and enumerate all the possible Windows protection methods. Right. Okay, and Clang format will make a mess of that. That's all right. It's okay. Okay, so now, what a fool! Oh, what an absolute fool! Right. What I'm going to do is say that, yep, missing switch, spotted it. I'm going to basically say that if we don't understand any of them, then for the moment, get that in a minute. Memory region protection. This will be no protection. So boom. Right, nice. I don't know why that's red squiggly, but I'm sure IntelliSense will catch up in a minute. If not, I'll give it a swift kick in the shins and see if that fixes it. Okay, that's enough to kind of get us going, right? So we can take the Windows specific representation of its protection and then turn that into our own frameworks, toolkits version. So let's try it. So now I should be able to go for const auto read. Can't type when other people are watching, which is great for live streaming. And then I should be able to do std println I might add a format for the actual region itself at some point, but then we've kind of gone through the mechanics of that. I don't think we really need to do it again today. I'll save that fun for myself. And region dot. Oh, I think someone asked what theme I was using. This comes up a lot. I use a theme called Dracula theme. You should definitely go and try it out. It's a dark theme full of pinks and purples, so it suits me quite nicely. Apologies, I just remembered I saw that and I meant to respond, but I didn't, which is very rude of me. Okay, let's see if this runs. An exception. Was not expecting that. Of course. We have now. I'm hoisted by my own petard. I can't. This will no longer work because we now have to handle the cases where it can be combinations of them. So let's go back and fix that. So we're no longer being able to return a string view because these are just fixed strings. These are just effectively statically allocated, so we can return a non-owning string view to them. But we're almost certainly going to have to build up a string. So one thing I want to point out, which I think is really, really cool, I don't know if you can see up here in the debugger where it's crashed, VS Code knows that this is a bitwise OR operation and has already pulled out the names for me. Like we need to do that ourselves for our program, but VS Code's like, no, I know what you're trying to do. This value of 5 represents these two OR together, which I think is pretty cool. Anyway, so this is going to want to return now a string because we're going to need to build this up as we go along, which is a bit of a shame. I like using string view where I can. I think we want to keep this. So let's handle the base case where it's just one of them. They keep making VS 2022 less and less relevant. Yeah, I cannot remember the last time I used like the full big Visual Studio. I just use VS Code on everything now. I really like value consistency, and the fact that VS Code works on Windows and Linux, and I do work on both of them, and Mac, I can just, and it syncs all my settings. I can literally install VS Code, I get my theme, my plugins, everything just works. It's absolutely incredible, and it's got half decent Vim bindings, so the weird muscle memory that I've picked up over the last 10 years kind of just works. How long have you been coding in my life? I've been coding professionally for about a decade, so it's been about a decade since I left university, which feels a long time ago. I think I started programming when I was like 14. I remember just like hearing that programming was a thing, and I was like, oh, I really want to learn this. It sounds cool. So I remember very specifically going to the library to their like programming section, and I just picked a book at random. Like I just picked one at random, and it was PHP. So PHP was the first language that I learnt, PHP 4. And I kind of reflect on this sometimes. I think I got quite lucky because I'm pretty sure also on that shelf was like books on XML, HTML, and SQL, and I could have just as easily picked one of those and thought that was programming. So in some ways, I think I consider it lucky I picked PHP. But yeah. I think my camera's slightly off as well. I just realised that. Ooh. Yeah. It's because I'm a bit of a fidget, so I often move around. Anyway, what are we doing? Oh yeah, we're fixing the bug. I think the best way of doing this is kind of stripping off. We can reuse this by stripping off each of these that we know is there, and then eventually we'll just be left with one that we know is there. Makes sense to me. Let's give it a go. So let's protections. Let's just create an array of all the ones that we know. Memory region protection read, memory region protection write, memory region protection execute. Right. So what I can do now is I can basically loop through these. So const auto mask. Sure, let's mask in these protections. So this is going to loop 3 times, and on each iteration I'll get one of these, and then I want right. what I want to do is if protection and mask equals mask, right? If this is in this, then do something with it, but this won't work, but we can make it work. And then I'm going to do what everyone tells you not to do and just copy and paste all my code because it does make life easier. I think that's right. Okay, so that should now, in a second, when IntelliSense catches up, disappear. Oh no, actually... Oh, it is. No, it's just terrible. It is just terrible code. Okay. Okay, so at this point now, we know that whatever this mask is in the thing that we were passed. Sorry. Yes. At this point, we've ascertained that one of these is part of the thing we were passed. So I think what we can then do is go return std format. I'm going to copy VS Code system because I quite like that. And then we can recursively call toString on the mask, which is fine because we know this mask is a single value, so it will get caught by this switch statement. And then we want to do toString protection. Ever used Vim? Yeah, I used Vim at university. I heard about this thing called Vim, and that, you know, it makes you faster at typing. You know, all the vitriol that kind of goes along with Vim, and I was like, I should give this a go. So I forced myself to use it for all my courseworks, which meant all my courseworks took a lot longer to complete. But eventually I did kind of build up the muscle memory, and then I used Vim for ages, but probably until like VS Code came on the scene, and I was like, it's more consistent. Like the, you know, it's got decent Vim bindings. You know, it just felt like a lot easier to like, get set up and running. So I haven't actually. I still use Vim if I'm on the command line. I need to go into a box or whatever and do something. It's still useful to know, but day to day, I'm using Vim bindings in VS Code. So how do we strip off a mask? That's XOR, right? That's got to be, because it's the only one we haven't done. Right, I think. Do code review me as I go along, because I will almost certainly miss one of these and then it won't work and I'll wonder why. So now, protection XOR mask. So if we had, for instance, let's work through this logically. If we had read write, then this would come through, it would find the read, it would format read, which would then come through and just print this, and then it would strip off the read and we'd be just left with write, which would then come through and do this. If we had read, write, execute, then it would strip off the read, it would then pass through write, execute, write would then strip off and print it, and then it would just be left with execute. I think that's right. Yeah, I've not used NeoVim. I'd like to give it a go, but I've got a system that works for me and allows me to be productive, and I don't feel there's a huge amount more optimization I can do in my work. I mean, I can always make things slightly better and faster, but I'm not in the market for like a whole like paradigm shift in how I work at the moment. I might get bored of VS Code and want something new at some point. Do I think that my code will always run in a C++ exception safe context? Yes, because for me, because I'm going to build it out as like a command line toolkit and a library that I kind of incorporate into the work that I do, so I know that's always going to be exception safe. I can't speak for other people, but I don't really, just trying to think of any specific, maybe if you're embedded, but if you're doing embedded, none of this is going to work anyway, because this is all to do specifically with interacting with Win32 and eventually Linux, so I'm pretty okay with using exceptions. I think it's, for me, I think it's the right choice in this case. Okay. So look at that. Right. We need to format this to be %x, but that's to be hex. I'm not too fussed about that. I think it's going to be OX. I think that's right. Yeah, I think that's right. Let's try run that. I won't bore everyone with writing all the tests for this. That's something I'll do in my own time, for my own amusement. Look at that. Right. I think we're done. Hopefully that was kind of interesting for people. It actually was more C++ kind of programming design than Win32 shenanigans, but that's just the way these things work. What I'm going to do is I think we're going to pause the programming there, but I'm happy. I've got a couple of other things to discuss, and I'm happy to answer any questions that people have whilst we're here, but hopefully that was interesting. I think like the argument of like returning error codes and expected versus exceptions is quite a big conversation to have. In my view, the API that I want to design is that I've asked someone to convert this to a string and it can't, and there's an error has occurred within this function and it cannot handle it in the current scope, then it's going to throw it up for another scope to handle it. This doesn't feel like a try and might fail operation. This feels like this should work, and if it doesn't, someone needs to know about it. It's kind of my view on it. I'm sure we will write some like try kind of functions where we'll either use expected or I'd probably use stood optional, that kind of thing. But yeah, that's just my view on it. I'm kind of very pro exceptions in C++. I chose C++ for this because I probably know it the best, and that does not mean I know it well or I'm an expert in it. I've been doing it for about a decade, but there's so much to learn and so many nuances to it. I would consider myself still quite a journeyman of the language, but it's just, the APIs are all in C, and I know C++ better than I know C, so it seems like a logical choice. I think it might be getting me confused with someone else because I don't think I've ever done Zig. I think I might have mentioned it once in a video about the JavaScript runtimes, but I've never written a line of Zig before in my life. Not saying I won't, and I love learning new languages. I'm very keen to give it a try. But yeah, C++ for me on this. Hopefully people find it interesting. It is a very, I'm gonna say fun language. There's a lot of nuance to it. But yeah. Before everyone disappears, I want to say that so there's a new video coming soon. It's available now for members, so I will release it maybe tomorrow, maybe Monday. It's a public holiday for us on Monday, so soon. But I do believe that I can, if this works, gift. There you go. Let me know if that worked, but 5 of you have randomly been given free membership for a month to the channel, which means you can now go and watch that video right now. So I hope you enjoy it. Will the app be available to the public as it can, and can it handle WinSock? I mean, there is no networking in it at the moment, and I can't really see a situation where we'll need any networking, but never say never. WinSock is an interesting beast. It would be fun to go through that on stream. So the app is available now. It's all on GitHub. Like I said, I'll tidy this up and stick it in the GitHub so people can have access to what we've done today. I don't know at what point I'll end this project, but I'll definitely be looking for another one afterwards. So maybe some networking stuff will be fun. Maybe do some graphics programming at some point. But I kind of want to focus on this at the moment because selfishly, it's very useful for me. But also, I'm hoping people are kind of enjoying it. I think we've had, again, pretty much 90 concurrent viewers, which is exactly 90 more than I expected. So thank you everyone for showing up. I hope everyone enjoyed it. I have nothing more to add, so I'll probably end it there. So thanks everyone for coming along, and I will try and arrange another one for next week.